Today we are going to discuss about 6 basic things related to bonding. We are here to help you with answers to the basic to advanced queries or questions that you have for me related to chemistry. While watching the video, if any doubt occurs, just type it in the comment section. We will try to answer those in the upcoming videos. So, without much ado, let's see what we have for today. What is valence electron? The electrons which are present in the outermost shell of an atom can only take part in chemical combination. This is why the electrons of the outermost shell of an atom are referred to as the valence electrons. The number of valence electrons of an atom in the outermost orbit is also related to its valency. What is the rule of the octet? The octet rule states that atoms gain or lose electrons to obtain the outermost electronic configuration closest to the noble gas. The force of attraction between atoms is measured informally by this law. The octet rule specifies electron placement on the orbitals of an atom's nucleus. It also determines whether electrons have been added or lost through chemical reactions, and measures the chemical reactivity of atoms based on their specific electron configuration. What is a duplet? What is duplet rule? An atom with 2 electrons in its outermost shell is called a duplet. Duplet rule is the tendency of an atom to acquire 2 electrons in the outermost shell. Atoms with a low atomic number such as hydrogen and helium followed the duplet rule. What is an ionic bond or electrovalent bond? The electrostatic force of attraction which holds the 2 oppositely charged ions together is referred to ionic bond or electrovalent bond. Electrovalent bonds are formed when electrons are transferred from atoms of one element to atoms of another element, forming positive and negative ions. The bond which is formed by the transfer of electrons between the atoms is termed as electrovalent bond or ionic bond. Electrovalent bonds are generally produced between metals and non-metals. Electrovalent bonds are not produced between 2 non-metals. How the formations of electronegativity and ionic bonding occur? An ionic bond termed as the bond formed by the complete transfer of valence electron to attain stability. This type of bonding gives rise to the formation of 2 oppositely charged ions, positive ions called cations and negative ions called anions. The presence of 2 oppositely charged ions resulting in a strong attractive force between them. This force termed as an ionic or electrovalent bond. Ionic bonds compose between atoms with large differences in electronegativity, whereas covalent bonds compose between atoms with smaller differences in electronegativity. The compound produced by the electrostatic attraction of positive and negative ions is referred to ionic compound. Examples of octet rule. We will today see the example of sodium chloride. Ionic bonding is composed between pairs of atoms. Here, one of the pair may be a metal of low electronegativity. A good example is sodium. The second one is a non-metal having high electronegativity. A good example may be chlorine. A chlorine atom in its outer electron shell is having 7 electrons. Here, the first and second shells contain 2 and 8 electrons respectively. The first electron affinity of chlorine represents at -328.8 kJ per mole of chlorine atoms. In order to add a second electron to chlorine, it requires energy. Moreover, energy recovery cannot take place by the formation of a chemical bond. What results is that chlorine makes a compound such that it has 8 electrons in its outer shell. A sodium atom certainly has a single electron in its outermost electron shell. Also, the first and second shells are full of 2 and 8 electrons respectively. For the purpose of removing this outer electron requires just the first ionization energy. Nevertheless, the first ionization energy is plus 495.8 kJ per mole of sodium atoms. This certainly is a small amount of energy. The energy requirement for transferring an electron from a sodium atom to a chlorine atom is certainly small, which is plus 495.8 minus 328.8 equal to plus 167 kJ per mole. Moreover, this energy can be offset with ease by the lattice energy of sodium chloride, which is minus 787.3 kJ per mole.